Welcome to the overview of the IIP-Ecosphere IIoT platform. In this video, we provide you with an overview of the platform. We describe the approaches we use to develop the platform from the vision to the actual platform. We will introduce you to the kinds of services the platform uses and how to build applications with meshes of services. We also give you a high-level overview of how the platform operates and how you can use it. And of course, how the platform will save you work by the use of code generation. The vision of the IIP-Ecosphere platform was to enable IIoT ecosystems connecting Industry 4.0 users across domain borders. Furthermore, the platform is meant to enable the use of AI in Industry 4.0 as easy and efficient as possible. Therefore, the vision of the platform had to cover key aspects such as ease of use of integration of AI solutions into applications developed and deployed with the platform, and open standardized information representation formats for Industry 4.0, such as the Asset Administration Shell. Starting from the vision of the platform, the creation of the platform followed the Industrial Internet Reference Architecture approach, in short IIRA. So we start with the usage view, which was created to capture the entities, roles and activities the platform needs to support. Based on the elicited activities, entities and roles from the usage view and the elicited technical requirements, the requirements of the functional view of the platform were derived. The overall process of gathering the information for the creation of usage and functional view is shown here. So starting with an open-minded survey of existing IIoT platforms, we concluded workshops to create a joint vision of the platform. Then we informed and interviewed AI developers and partners from the industrial production area to identify further areas the IIP-Ecosphere platform needed to address. And based on the joint vision, with further workshops and detailed surveys were performed to inform the creation of the usage and functional views. Based on the created and validated usage view, we derived necessary and desirable activities the platform needs to support. Next to the necessary technical activities, the platform needs to support of particular interest here were all activities that relate to the development and use of AI applications in Industry 4.0. From the identified and verified activities, the necessary technical requirements as shown here for the platform to support the identified activities forming the platform architecture were derived. This is a high-level overview of the building blocks of the platform. As mentioned, the overall goal is to enable service-based AI-enabled applications to be deployed to available resources utilizing standardized protocols. Therefore, the platform encompasses on the two lower layers the platform internal data transport, connectors to the external data, for example to machines, basic service interfaces, resource abstraction and monitoring facilities. These two layers form the basis of the application that can be deployed to edges, servers or the cloud. The remaining upper layer adds services on data protection, data integration, AI runtime adaptation, centralized monitoring, configuration and deployment of services. The platform describes itself as well as all of its components, interfaces, functions and deployment targets in terms of asset administration shells, or in short AAS. Thus, each of the components of the platform and the platform itself, each of the components that forms an individual asset has an own AAS. As the platform is service-based, it is shown here which services the platform offers and supports. The platform offers and supports three kinds of services. Platform-provided services is generic, parameterized services that offer functionalities for various technical tasks such as deployment, monitoring and data sharing that can be applied to various settings and tasks. Application-specific services, which are often AI services, can be developed and used as part of specific applications operating on the platform. Hybrid services are typically generic platform services that can operate without application-specific code, but can be customized through add-ons or plugins to support a specific application, enabling the hybrid services to form application-specific tasks. Services are typically connected to other services of different kind, ranging from data sources over transformation services to data sync services, forming a service mesh as shown here. The basic approach is to chain generic parameterized platform services to get data from a source, link this data to further processing or transforming services, for example, an application-specific AI service that works on the data from the source, for example, transforms the data and passes the output of these transformer service to a data sync via another generic parameterized platform service. So instantiated connections between services are called data paths or relations and are defined as part of the application in the platform configuration. As stated, the basic idea of developing an application in the platform is the orchestration of services into an application with platform services, one or more application-specific transformer services, and optional hybrid services forming a service mesh. Several kinds of data connectors form the links between the services in the service mesh and the connections of the application to the platform in general. Communication between the orchestrated services is coordinated by platform-provided message brokers, implementing common message formats and protocols such as MQTT and OPC UA. Several examples for applications for specific tasks and their subsequent service meshes are available on the platform GitHub. Services can be deployed and executed in a distributed manner. This is supported by the Edge Cloud Server, or in short ECS runtime environment, and the message brokers of the platform. To ensure the correct coordination and interaction between services deployed to and executed on distributed devices, the platform employs the information representation format Asset Administration Shell, or short AAS, in two ways shown here. In a local way, on-premise deployment of services is shown here in the diagram D1 on the left side. Remote deployment, for example, or distributed deployment, for example, off-site or in a remote cloud is shown in diagram D2 on the right-hand side. To handle requests of AAS in a remote resource deployment as shown in D2, the resource must run a further server instance of the resource AAS server. Both deployment scenarios are coordinated by a central AAS server of the platform. This is a slightly simplified overview of the start-to-finish component interactions within the IIP-Ecosphere platform during the general life cycle of services and their subsequent application in the platform. The left-hand side shows the user interface from which you issue commands to create containers for services and artifacts, for example, AI models, using the ECS runtime of the platform. Then, how you deploy the service manager of the platform and create and add services and/or artifacts in the service environment via the service manager. Start the services in the service environment, and subsequently, once the services are not needed anymore, it is shown how you can stop the services and undeploy services and artifacts, and finally stop and remove the containers in which the services and artifacts were deployed. It's also shown how the central platform AAS is involved in the coordination of all of these steps. The IIP-Ecosphere platform generates much of the necessary glue code, such as configurations, connectors, services, application descriptions, and AAS descriptions of components automatically from configuration files. This automated code generation is employing the integrated variability modeling language, in short IVML, in which the platform, the services, and application configurations are described within the platform. The reasoner that performs the code generation also performs a consistency and dependency constraint check before generating the code, therefore assisting by indicating defective configurations even before any code is generated. The process is not detailed here, but you can see this process more detailed, for example, in the platform handbook. A number of publications are available for you to get further insight into the IIP-Ecosphere platform. Furthermore, you can of course obtain the IIP-Ecosphere platform via our GitHub link shown here. And thank you for your interest in the IIP-Ecosphere platform. Please feel free to contact either me or the project team for any inquiries or further questions regarding the IIP-Ecosphere platform. Thank you.